S-curve. Product and technology development. Structured innovation. What is S-curve? S-curve is a display of cumulative things or quantities, plotted against time. This name derives from the S-like shape of the curve, flatter at the beginning and end, and steeper in the middle, which is typical form. S-curve can be used in defining the growth of any system, like business, product development, costing, etc. The horizontal axis indicate time frame of the product, and the vertical axis represent performance of the system, or product, or technology. Also vertical axis represent the maturity value or the performance of system, which are measured against the time. What is mean product and technology S-curve? In related to the product development, S-curve define the various stages of the product, starting from the conception of the idea, till the absolution of the product. It mainly starts with conception of new idea, which define the product to address some problem through some functionality. Further there is improvement, and at one stage of time, the same functionality can be achieved by other product, or functionality get displaced by some newly formed functionality. Every S-curve have three major region. First region indicate the initiation of concept or idea. This phase is in the beginning of the S-curve pattern of innovation. It is when the product or industry is completely new. The next phase is takeoff. In this phase, due to the ability to overcome a major technical obstacle, or the ability to satisfy a demand of the market, the product or industry have been adopted by the early majority, and managed to attract investment, and become a dominant design. Hence, the market will be characterized with a rapid growth in production, and the product will move quickly towards a full market acceptance. Next phase is maturity. Here, the product is adopted almost completely by society, and is usually approaching a physical limit. Due to the strong competition among the major players in the market, which is clearly defined at this stage, most of the resources at this point are spent on improving the production processes, and making them cheaper. Therefore, oftentimes the products at this stage become completely standardized, and the innovations at this stage are considered incremental. The last phase is discontinuity. At this phase the innovation occurs, as a new S-curve pattern can rise. Since the previous product or industry reaches an era of maturity, there is an opportunity for a new product to appeal to the innovators segment in the population, and they will start a new product life cycle, which is usually considered as the disruption. This is the overall glimpse of the S-curve. Now the question is, why the S-curve is important, or why people tend to establish the S-curve for the product, or technology, or for specific industry. Why S-curve is so important to many people like technology leader, investor, researcher, technology managers and fundraiser etc. S-curve for product or technology provide lots of data related to the business, which can help in taking decision related to the product, or technology development. For technology leader or technology organization, S-curve can be used to evaluate the technology opportunity for business. This will help in placing the technology strategy and the investment, along with resource planning for R&D effort. For the business manager, it is more important to understand where are the opportunity for the business, and what can be the new avenues for improving profit. S-curve helps business leaders in understanding the technology evaluation, and their displace. This helps business leader in taking appropriate decision for resources management, business acquisition and merger, or venturing with new technology partners. Next, for investor, it is a question of return on investment, and where to invest. S-curves support investment decision related to technology stream, and also, may provide different application opportunity on same product line. This also helps in the generation of new market due to change in the technology, which create the new function, or the new opportunity for supporting the new technology. This is another opportunity for the business for investment in the supporting structure. Overall, S-curve for product development will always in sync with the technology development S-curve. In term of technology origination, S-curve helps in defining the focused for technology development areas, and help in selecting innovation strategy, by providing the canvases for opportunity in the business. Let's see how the S-curve keep track of product evaluation. S-curve initiate with new product or service, which either provide existing functionality, or functionality with significantly modified form, to the user. This is new idea and probably need to prove in the market. This is the stage where idea is born, however still on the paper. This idea need to work. So proving the concept, and making prototype is the important aspect. Many of the ideas die down during this stage. There can be multiple reasons for this, however development of prototype, and prove the concept needs significant time, and effort. This is where investment is required for the innovator. This investment can be obtained from individual, investor, or company. There are different ways to make the idea work, especially these days. People are more relying on mathematical modeling and simulation to evaluate the concept, and understand how it works. Prototyping is also a good idea, however it takes a lot of time to learn inside of the system. Rapid prototyping is the emerging technology, where people are greatly depending in these days to evaluate their idea, and make the system work. Next important milestone is, make the idea work properly. That is to provide a minimal functionality what is expected by the intended user. The learning obtained from the previous stage, need to be utilized and improve the working of the system. The innovator, or initial investor can support this activity through funding, but moving ahead from this stage needs significant investment in terms of developing a manufacturing and distribution system. At this stage, idea is open for the larger investor and early adopter. Now product support the functionality, however doesn't provide the guarantee for the better performance of the system, compared with the older, or existing system in the market. Idea is in market now, and immediate reaction from the user is expected. This is good to improve the learning curve. Better the learning curve, better the market dominance for providing solution over existing product. Once the learning from the market started, immediate demand from the user is to improve the performance. This is to reap the benefit over the older system. These demand is from early adapters of new product. This is the start of major R&D within the system. In addition to the improved performance, system get better and better, which increase the demand of the system in the market. And system starts penetrating the market for common people. In very short span of time, competitor arises, and there are similar system exist in the market. There are many users and customers. The differentiation parameter need to be established. Majority time efficiency is the first parameter which need to be addressed. On other hand, to improve the customer base, and making the system available to common people, efficiency need to be improved. Here onward, continuous improvement in the efficiency is expected as the system get mature. The next differentiator key for the product become the reliability, which is expected for larger customer base. This need rigorous effort to meet the competition. As the product keep maturing with respect to time, cost of R&D effort increase the overall product cost. This is where effort on cost minimization initiate. This is also essential, as many of the local competitor arises with respect to time, and performance of the system is not an issue for the quality offered by them. The way product mature, production of product become more localized, and the profitability decreases. This is the time many of the larger investors stop investing in the product, and looking for new product which can address same functionality with more effective way, something like reducing the time, effort, cost of operation etc. Now let's talk about technology. If this curve looked through technology perspective, there is not much interesting thing happening in the S-curve. This is more generic, and need to be tuned so to provide the technical details about the system. For this it is necessary to understand how the system utilization, user interface and in-depth understanding on how the working environment is. So, for technical S-curve, S-curve need to be redefined, to understand the technical system, technology trend and challenges for engineering department. First it need to understand what is the information engineering team will be looking for from S-curve, and how S-curve can help people in defining probable solution. The objective will be to understand how the customer offering can made to deliver innovative and successful product. Before we move ahead, let's see how the technology development cycle move with the maturity of the product. At first point, new system starts with a promising idea, which intended to generate new uses. In new system, many parts come from old system. This is because functionality of the new idea remains same, however few of the items are changed to achieve the functionality. This we called as a system. Now the question is, what does the system mean and how the innovation, or solution is being persuaded as a new idea? As per TRIZ, the system is defined as a combination of engine, transmission, actuator and work object with controller mechanism. The engine is a component which provides a power to the system. So it takes the basic form of power and deliver to the primary form of power on which system can function. Further, this power is taken to the transmission, which govern the power as per requirement, and allow to flow further. This power is consumed by the actuator, which mainly convert the obtained power into the most useful form. This output form depends on what you are looking for. Maybe the system is used for increasing the temperature, rotating the object, increasing pressure, or something else as per function. At the end there is a delivery system which transfer the obtained from to function work on the work object. So work is being done using the functionality provided by the actuator. So this was about the system. Now any component get replaced in the system which can offer an improved functionality, will be perceived as a new idea. Further economic benefits define the quality of innovation. There is one more component to be added in the system. This is control. At initial stage most of the time control to the delivered function will happen through human sense, however with maturity of system this control will become an imbibed part of the system. So from technical system point of view, any change in the defined system, which can bring positive result is a new idea. Next step in system development is, the system start working and providing the functionality with incremental value addition. However, in term of tangible benefit some new function get added in its main system. At this point of time, performance of the new system is worse than old system, however new function is something, which was not thought exploitable from the previous system. In term of technical term, new system initiate maturing on functionality. Now, the new system have to resolve the problems in order to work properly and work better than older one. This is where complete system form and conversion of idea into useful product is made. During this development processes, few of the new elements get added in original idea which improve the delivery of intended function. Idea is now ready to sell on the market. However, still significant improvement needed. The early adapter are ready to buy the system and experiment for available opportunity. Cost at this time is much higher, and proportion of the value to cost cannot be well justified. This is a stag, where major investment is required to produce the system at larger level to reduce the cost. Mass manufacturing is the easiest method adapted at this stage. As the volume of the system grows, there is also improvement expected in the functionality of the system for larger customer base. Next move for the system is to establish its volume and market potential. By this time, main useful function is proven and value for the acquisition of new system is delivered. Early adapters mainly drive market and provide lots of inputs for the development of the system, which is the significant part of the system development. The volume grows and the functionality start growing, as the early investors start different ways of exploiting the system. With respect to time the value gained by exploitation of system increase and the many user join the larger follower group. By this time the development in the product is not on the technology, but identification of various use cases to prove the value to the customer and establish multiple functionality, which might not exist in the previous system as a focus. This is how the engineering effort moves to add functionality which can provide benefits to customer in different way. Now the system is getting well matured, and not to be considered as a new system. The demand and improvement of the system starts speeding up. Improvement in the overall performance definition get redefined, and various parameters get added in the system design. The ideality of the system gets start increasing. Let's see how the ideality is defined by TRIZ. A system's primary objective is to perform function. The ideality of system can be defined as a ratio of main useful function to the total of waste and harmful function. Ideal system will be zero waste and harmful function. The ideal system will be the system which perform the functionality, however the system doesn't exist. The existence is what defined by West. W stand for the weight of the system which contribute the material and manufacturing cost. E denote energy consumed by the system to perform the functionality, and definitely the cost associated with the use of energy. The next element is the size. This is about the consumption of the space which is a burden on the user or the larger level system, where new system is trying to becoming the integral part. And the last component is time. This is about consuming the time or human resource. After all, time is a money. Now coming to the harmful effect. They are majorly on the side effect which are caused by the use of many components in the system. Like the energy need to be consumed, so to produce there is a pollution to be happened. If the electricity is being used, there is heat generation to be happen. If there is a rotating machine power to be used, noise to be happened, these are the harmful effect. Now at this stage of maturity, system are being used by many people and the improving ideality is a key parameter for bringing the distinguished product, which propel the technology. So technology focused start getting defined here. This is to improve the ideality. Now, how the ideality is being improved. The previous example of the system definition, which consists of engine, transmission, actuator, plays a crucial role. The appropriate change in the system element or elements can help in improving the ideality of the system. Technical people are the better judge on how the change can be brought. From technical strategy point of view, this is a stage where highest invention are made by manipulating the basic system element. The invention made at this stage are valued very high. Here the system is integral part of the original visualization of idea, impacting largely and increase in sales. The organizations start exploring new market and new opportunity. The customization for the local requirement or market-specific application start, and the new system get generate. These new system are more related to the original idea, however the functionality differ at larger level, due to difference in the targeted customer, or the market. In order to make the system suitable for the new market segment, there is a need to merge the technology, and this is how system starts becoming complex. Controlling the system more difficult, and the need for operational improvement increases. People tend to expect more from the system. This adds a new dimension in the system. That is better control over delivery of function. At this point, systems start become auto-control, commonly called as a closed-loop system. This is the focus of the technology at this stage. So here you can see that this is a stage when the technology is getting mature and improving the ideality and functionality for betterment on control. Commercial activity are increasing drastically, and the support required for these commercialization activity need support from large manufacturing. This is where the manufacturing technology start taking shape, to make the system available with larger variant. It has to be noted that the cost is not the prime mover of the system, only the delivery of functionality of the system is pulling the market. In next maturity stage, increased commercialization activity and customer base, increase profit, and eventuality improve the sustainability of the system in long term. People completely believed in this system and considered as one of the must-have tool for improving their larger level system performance. This confidence bring the new opportunity in the society. New ideas for the support of the mature system get generated to push the performance further. This new ideas keep adding the new customer and increase the width of adaptation of system, at a larger level in various field. The technology required for the adaptation, and the better control of the system will be the main focus at this point of time. Most of the effort goes in making the system more flexible in adaptation, considering the further application which are not yet thoughts. This help and bring more variant, and standardization start become a focus. This is for the improving the interchangeability of system, which are offered by the other upcoming industry to meet new customer requirements. As the belief of people keep on increasing on the system, use and support industry start grooming up. The system becomes so popular and get integrated with many of the system, there is a need to have larger system to support. Like driving school for the vehicle, servicing centers and insurance system etc. With respect to increase in support system, cost of operation start increasing, and also the risk associated with the dependency on the system increase. To reduce the operation cost, automation start become the integral part of the original idea, and system keep on evolving. For the technology perspective, it has to be noted that the training, standardization of the part, counterfeiting technology and the automation is one of the area where strategy need to be focused to improve the sale. Now the time come where the system is considered as an old idea and start consuming huge resources. Consumer got in-depth understanding if the system and many supporters of retrofitting systems are available in the market. Still the system keep on evolving considering the ideality function, still there is a large scope for improvement in the system. It has to be noted that the increase in the profit will not be same at this stage. Also during this time there is not much change in the basic technology, the more focused was on the improving the control and efficiency of the system to satisfy larger customer base. Here onward, more customization drive expected to satisfy the smaller unattended market. The flexibility in the control system and components retrofitting help in improving this market. This is a stage where new experiment with other technology starts. The focus from improving the energy efficacy and control moves to the operational efficiency. This also help in focusing regional and more specific tasks performing market. The smaller customization market also drive the ideality improvement of the system in terms of reducing the size and energy consumption. This is in an effort to maintain the cost of customized system at lower end. The effort on improving the operational efficiency drives the part of automation, and addition of new technology bring the intelligence in the system. This is the new generation of the system began. Since the system become extremely popular, they start consuming huge resource, which brings some human designated norms. This is more on the environment effect due to overuse of the system. The norms made by the government push the technology of the system further. In particular to the experimentation done at the smaller scale in earlier time, they become norms to meet the technology. This is a stage, where old technology get mutated with new technology, and improve the performance of the system. The major R&D efforts start here. R&D is not only for the improving the performance, but also to reduce the cost of the competitor. This time local market get flooded with the more customized solutions as per geographical region. Note that, experimentation technology insertion starts new trend of system. They can be a probable ideas which can initiate new S-curve. Since there is more scope for experimentation of the system in such condition, demonstration of the systems for specific application become a priority for the by larger player. This is where the technology focus moves and system keep on evolving with addition of functionality. Now the system have much more functionality than the intended design. Technology focused is more on bringing the flexibility to interact with other similar system at much larger level. This normally impact on the way overall operation is being done at a larger supersystem level. As mentioned, government regulation bring the focus to attend the harmful function of the system. This is to make the system more safe, and increase the sustainability of the larger system level function. There is not much remaining in term to improve the product functionality at this stage. In term of R&D effort, focus start moving to the new system which are being developed during the experimentation phase. This is more on maturing concept prototype. Systems start getting revamped with new concept, and the more S-curve start at this stage. This new system show promising performance, in at least one area. Funding starts for this new idea. The original ideas start getting absolute. In absolution phase, the cost of old system become very less, and this low-cost system found new applicant which are more on the commodity kind of work, and this work is definitely not for intended use. In the last phase of the system, main function of the system get challenged by the newly formed system, and new system get take over the intended use of old system. At the end of technology S-curve, obsoleted technology being used in the system which are not intended to support original functionality, but the use is more on the social aspects, or entertainment aspects. This particular template helps in the understanding of evolution of the system, in terms of the probable technology challenges faced by system evolution and maturing phase. Few of the points to be noted that, the development of most of the system follow similar path, because of few reasons. The major factor is, ununiform growth in the supporting technology. The uneven development in various technology field add the integration challenges on adaptation. And engineering effort keep on following these challenges. Most of the time, challenges are addressed by addition of few more system, which make the system more complex. This complexity result in few of the challenges related to reliability, which need to be again addressed by evolving other technology. And this is how product related to technology keep progressing by addressing the challenges, and follow the similar path followed by most of the product related technology. This path can be more predictable, provided understanding of the complete evaluation of the product cycle.